Hello, today's lesson is on rate of change. So there's lots of different ways in Algebra 1 and Algebra 2 how we kind of define what rate of change is. It's a fancy way for, let's see, in Algebra 1 I know you learned about slope of a line, rate of change. So it could mean, let's see, change in y divided by change in x. I use this one the most just because it's short and sweet and easy to write. When you're dealing with graphs, you probably remember hearing rise over run. That's your y change and your x change. It could also be the change in your dependent variable over the change in your independent variable. And then there's a fancy little formula to find rate of change, to find slope, which was that y2 minus y1 over x2 minus, x1. Now, everything I just wrote down all mean the same thing. We've got rate of change, slope, it means this, and this. So all of that, write it down so that when I say any of these individual things, you know what I'm referring to. All right, so looking at a table of values, I don't have the full scenario here, but we have enough to kind of make sense of it. I have minutes and total charge. So what will be X, what will be Y, independent and dependent? Well, usually your money is depending on something. So maybe you're renting something by the minute. So that is your independent variable. So I've got X, I have Y. So if I want to find the rate of change, oh, it looks like these zeros got pushed down. So that was just supposed to be 20.00. I didn't notice that. Okay, no worries. So I want change in Y divided by change in X. So how are my Y values changing? They're changing by 2.5 every time. How are my X values changing? They are changing by 10 every time. So the change in Y, my Y values are changing by 2.5, and my X values are changing by 10. So what is 2.5 divided by 10? It is 0.25. And that is money per minute. So there's rate of change from a table. Okay, finding rate of change between 2 points. So this is the classic formula, M equals y2 minus y1 over x2 minus x1. Change in y, change in x. So we're going to do 3 different examples. The first one, -2, 6, and then 4, -10. So I've got an x and a y, an x and a y. This y2 and y1 is just like the y from my second one, the y from my first one. And I need to find the change. So what is -10 minus 6? -10 minus 6. And then find the change in my x. So 4 minus -2. So if I simplify here, that's going to be -16 over 6. And then we always want to simplify fractions, so that's going to go down to -8 over 3. Okay, next example, let's look at 2, 1, and 2, 7. Find the change in my y values, 7 minus 1, over the change in my x values, 2 minus 2. Oh, well, there actually wasn't a change in my x value, so that would be 6 over 0. Can't divide by 0, so this rate of change is undefined. Okay, and last example like this, let's look at 3, -8, and 4, -8. All right, my y values, -8 minus -8. Well, I want you to think from -8 to -8, that's not changing at all, that's 0. And then my x values, 4 minus 3 is 1. I can do 0 on top. 0 divided by 1 is 0, so my rate of change is 0. Okay, last section, rate of change of a graph. And this is where we like to always say rise over run. Change in y, change in x. Now, when we're reading graphs, it's really important. We read them left to right. So this line, if someone was walking this line, yay, from left to right, they're going downhill. If someone was walking this line left to right, they're going uphill. All right, so rise over run. What you want to do is find 2 points. Start at the left point, your rise meaning up or down. I'm going to go down 2 and right 3. So my rate of change is -2/3. All right, the next one, if you draw the rise over run, it looks like it's going up 1 over 1. But look at your units. So from 12 to 18, it's actually going up 6. And then over 2 to 4, it's actually going over 2. So the rise is 6, the run is 2, which is 3. So there's your full lesson on rate of change, finding it in a table between 2 points and on a graph. Good luck with the lesson.